You are tuned to ARI Learning, and I am your host, Teacher. In this Mixtures and Separation lesson, we will examine the classification of mixtures. Check the description box for the links to all the videos associated with this unit. By the end of this lesson, we should be able to classify mixtures as homogeneous or heterogeneous, distinguish between compounds and mixtures. We start with the classification of mixtures. Mixtures are classified into two main groups, homogeneous mixtures and heterogeneous mixtures. Homogeneous mixtures have a uniform composition and the components mixed are not distinguishable from each other. For example, it's not easy to distinguish between food coloring and water after the two have been mixed. The mixture has a uniform appearance, as we can see in our photograph to the right of our screen. Examples of homogeneous mixtures include clean air, which is a mixture of colorless gases including nitrogen, oxygen, carbon dioxide, water vapor, inert gases, and a few others. Then we have steel, which is a mixture of iron, carbon, and other metals such as chromium or nickel. And note that a mixture consisting of two or more different metals is called an alloy. We also have bitumen, which is a viscous mixture of organic compounds called hydrocarbons, and they are obtained as the residue of distilled crude oil. Now, bitumen is used for waterproofing roofs and in making asphalt to surface roads. Heterogeneous mixtures, on the other hand, do not have a uniformed composition. The different components are distinguishable. That is, you can see the different parts or features. Taking a look at our photograph on the right of our screen of sand and water mixture is heterogeneous because the insoluble sand is observed separately from the water. Examples of heterogeneous mixtures include a fruit salad. You can see each fruit separately. We also have a chocolate chip cookie. It's also heterogeneous because you can see the chocolate chip separately from the rest of the cookie or the dough. Then we have a mixture of wheat grain with glass beads. This is also a heterogeneous mixture because you can see the wheat grain separately from the green glass beads. It's classification time. You will have 3 seconds to classify each mixture shown in the photographs as either homogeneous or heterogeneous. What type of mixture is this? Sand and water. Heterogeneous. Food coloring and water. Homogeneous. Wheat grain and glass beads mixture. Heterogeneous. Mixed nuts. Heterogeneous. Brass stopcock. Homogeneous. Whipped cream. Homogeneous. If you got all answers correct, give yourself a pat on the back. We will now compare compounds and mixtures. A compound is a pure substance. A mixture is an impure substance. A compound is always homogeneous. A mixture may be either homogeneous or heterogeneous. A compound has a fixed composition. Substances are chemically combined in a fixed ratio, while mixtures have no fixed composition and the substances are not chemically combined and are mixed in any ratio. The formation of compounds involve a change of energy, while the formation of mixtures do not involve a change of energy. The components of a compound, if possible, can only be separated by complex chemical reactions. The components of mixtures, on the other hand, can be separated by simple physical methods. Lesson summary points. Homogeneous mixtures have a uniform composition. Air, steel, and bitumen are examples of homogeneous mixtures. Heterogeneous mixtures do not have a uniform composition. A fruit salad and sand and water are examples of heterogeneous mixtures. Compounds are pure substances that are always homogeneous in appearance, but mixtures are impure substances that can be either homogeneous or heterogeneous. Components of compounds are chemically combined in a fixed ratio, while those of mixtures are physically combined in any proportion. The formation of compounds involve energy changes, but the formation of mixtures does not. The components of mixtures are separated by physical methods. It's quiz time. You have 5 seconds to answer each question after it is read aloud. Question 1. Which of the following is an example of a heterogeneous mixture? A. Orange juice. B. Seawater. C. Air. D. Steel. The answer is A. Orange juice. Question 2. Sam has two mixtures, X and Y. X was a mixture of sand and water, while Y was a mixture of salt and water. Which response correctly classifies mixtures X and Y? Option A. X homogeneous, Y homogeneous. B. X heterogeneous, Y heterogeneous. C. X homogeneous, Y heterogeneous. D. X heterogeneous, Y homogeneous. And the answer is D. X is heterogeneous, which is the sand and water, while the salt and water mixture would be homogeneous. Question 3. Identify the mixture that is correctly matched to its classification. A. Steel. Classification heterogeneous. B. Bitumen. Classification homogeneous. C. Seawater. Classification heterogeneous. D. Oil and water. Classification homogeneous. And the answer is B. Bitumen, homogeneous. Question 4. Identify the statements that are correct about mixtures. 1. Mixtures are impure substances. 2. Mixtures are pure substances. 3. Mixtures can be homogeneous or heterogeneous. 4. The components of mixtures are separated using simple physical methods. The options we have are A. 1 and 2, B. 2 and 3, C. 2, 3 and 4, D. 1, 3 and 4. And the answer is D. 1, 3 and 4. Question 5. All statements about compounds are true except A. Compounds are pure substances. B. Compounds have a fixed composition. C. Compounds are always heterogeneous. D. Compounds are not easily separated into the elements from which they are made. The answer is C. Compounds are always heterogeneous. That is the incorrect statement. As we know, compounds are always homogeneous. We have reached the end of our lesson. If you found this video helpful, remember to like, share, and subscribe. When you subscribe, you will receive notifications as new videos are uploaded. So until next time, I am Teacher with Irie Learning.